Hello everyone, in this video we'll see the last part of our chapter concerning capacitors, and it is about grouping of capacitors. Enjoy! Equivalent capacitor. By definition, it is a capacitor having the same electric effect as a group of capacitors connected to each other. What do we mean by same electric effect? It means that this capacitor may store the same amount of charge as the grouping when connected across the same voltage source. And of course, the capacitance of this capacitor is called equivalent capacitance. Parallel grouping. Of course, in a parallel grouping, we always apply the uniqueness law of voltage, so that the total voltage across all the capacitors is equal to the voltage across each one of them. Now, instead of saying that the current in the circuit is additive, we will say that the electric charge is additive, which means that the total charge of the grouping is equal to the sum of the charges of each one of the capacitors connected in parallel. We also know that the quantity of electric charge, Q, is equal to C multiplied by U. Now, by substituting this relation in the previous one, we get C multiplied by U is equal to C1 times U1 plus C2 times U2 plus C3 times U3. And since the voltage is the same, we may simplify by U. Then, the obtained expression of the capacitance represents the equivalent capacitance of the grouping. Therefore, C equivalent is equal to C1 plus C2 plus C3. Series grouping. Instead of saying that the electric current is unique, we will say here that the electric charge is the same. In other words, the total quantity of electric charge of the grouping is equal to the charge of each one of the capacitors of the grouping. And of course, the voltage is additive. So the total voltage of the grouping is equal to the sum of the voltages of each one of the capacitors. We also know that U is equal to Q over C. Then by substituting this relation in the previous one, we will get Q over C is equal to Q1 over C1 plus Q2 over C2 plus Q3 over C3. And since the charge is equal, we may simplify by Q. And of course, the capacitance C represents the capacitance of the whole grouping. That's why we may get the expression of the equivalent capacitance, which is given by the relation 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Thank you.